Hi viewers, this is Dr. Gunamani Jana and you are watching video with me on database management system, and in this video we are covering the chapter 1 of this database management system. Here we will be covering the basics of the database management system, the purpose of database management system, view of data, data models, DDL, data definition language, data manipulation language DML, transaction management, storage management, database administrator, database users, and overall system structures. So these are things we are going to cover. As we have studied in our video 1 regarding the database management system and specifically the RDBMS. So we have an overall idea that this database management system is a collection of interrelated data, and it is a set of programs to access the data. This is the thing we know. Database is collection of interrelated data, and database management system is a set of programs to access that data. And this DBMS, it contains information about particular enterprises. For example, this DBMS provides an environment that is both convenient and efficient to use. What are the applications? I talked about that it is suitable for particular enterprise. For example, we go for the banking, all the transactions we can do using this database. Airlines like reservations, schedules, etc. We can make it with the database applications. Then the universities, the registration grades, everything it can be maintained. Sales, customs, product and purchase, all things we can do with that one. Then all the manufacturing industry like the production, inventory, order, supply chain, then human resources in any company like the HR and all things, the employee records, the salaries, the tax deductions, everything. These are the minimum database applications we day to day use all the things. Then this database touches all aspects of our lives. If it is from a small business or small organization to big one, everything is covered by this one. Then in the early days, database applications were built on top of file system. Okay. So as I given the example, it is the XLS or the CSV file. On that only we are maintaining the database. And there are a lot of drawbacks as I have shown you. This using the file system, we have a number of limitations. That is the data redundancy and inconsistency. The first one. Suppose there will be maintained by multiple files and in multiple formats, so it creates a problem while retrieving. Then duplication of information in different files also will be there. Then difficulty in accessing data. So you need to write a new program to carry out each new task. That is one of the toughest job here. Then data isolation. Suppose multiple files are there and it multiple formats, so it creates a problem because data isolation means as if the entire data we are going to isolately access one file, but because it is multiple files and formats, it creates a problem. Then the integrity problem, integrity constraint. For example, nowadays in some banks they are putting the minimum balance should be 5,000 or more than 5,000, or at least the State Bank the minimum balance should be greater than 500 rupees. So who is going to check? Because everything is online. You are going to withdraw through ATM and withdraw all the amounts. Say for example, there are 10,000. You withdraw all the 10,000 rupees, but there must be some constraints. So you cannot withdraw that minimum balance. So this integrity problem is clearly the problem in the file management system, but it is easily taken care by the database management system. Then add add new constraints on changing. Suppose initially the minimum balance was 500 rupees. Now the bank wants 5,000 rupees, the minimum things. Then it is difficult to create. Then drawback of using file system. Then the atomicity. Atomicity, as you know, either the entire transaction is to be carried out or none of the transaction to be carried out. That means it has to roll back to the previous state, right? So already I have given the example in our video lecture 1. Please refer. Then concurrent access by multiple users. Suppose the same account is accessed by multiple users. Suppose your dad's account you are accessing, your sister is accessing, your mom is accessing. Because it is online, they can access and they can transfer money and they can withdraw. So in this case, it creates a problem in case of the file management system, because it cannot be updated simultaneously. Got it now? But in case of database management system, it is possible. Then there is security problem. Database system suffer solution to all the above problems. That is the reason we are going for the database management system. Then the next thing we come across the level of abstraction. we are having three level of abstraction in the database management system. One is the physical level abstraction, second one is the logical level, and the third one is the view level. View level is the top one. Physical level, it just describes how a record is stored. For example, I want to create a table customer or database customer. How the record it is stored, that is shown in the physical level. In the logical level, it describes data stored in database. For example, I say customer. So type it is a record and name is a string and street is a string and city this is the name and address and all things. So this is the syntax how you put the data in the logical level. Then the view level. Here application programs hide details of data types. If you can also hide the information, that is the suppose you are the somebody other than relevant, so you need not know other salary, so that's why salary can be hidden to you. So this is the view level. I show an diagram here, you can clearly understand. Physical level is the lowest level of abstraction, above that is the logical level, and the top is the view level of abstractions. And you can have a number of views, and you can hide all the details, or you can hide the so many things, and what is only relevant that you can show. Okay, so this is the architecture of the database management system. Then coming to the instances and schema, this you can compare or analog to the variables in a programming language. Suppose you are talking about C or Java, we declare a variable x and x is equal to something 25. Okay, so this is a variable and value you put it there. So it is just like that. We go for the instance and schema. So what about the schema? Schema, it is just the logical structure of the database. What mean it says about for a student, there should be a name, there should be a registration number, there should be email ID, but what is the name is not mentioned there, and what is the registration number it is not mentioned there, and what is the address, email ID, and mobile number is also not given there. But it is telling if it is a student for that schema, these are the things is required. You understand? So this is just we call it as the schema. And we are having also two type of schema, the physical schema and the logical schema. Physical schema, that is the database design at the physical level. Logical schema, this is the database design at the logical level. Then what is instance? Okay, we got some overall idea. This schema, it is just like no something a template. Then what is the instance? The actual content of the database at a particular point of time, it is analogous to the value of that variable. So for example, I say variable is x. So x means it is a variable, nothing is there. But I say variable x and x is equal to 25. So instance of that variable x is 25 at that particular moment. Understand? So x is the schema here and 25 is the instance of that variable there. So in that way, we can explain the schema is just like a variable and instance is just like the value of that variable at a particular instance of time. Then we are having the data independence. We are having the different type of data independence. First one, the physical data independence. The ability to modify the physical schema without changing the logical schema. This we call it as the physical data independence. Then the application depends on the logical schema, as you know. And in general, the interfaces between the various levels of components should be well defined so that changes in some part don't seriously influence the other. Okay, so this is about the physical. Then we go for the data models. We are having a collection tools for describing the data models, like the data is required, when data relationships is required, data semantics means your meaning, data constraints, some restriction is there. And also we are having, this is the tools we require for defining the data models. And we are having entity relationship model, we are having relational model, we are having other models like object oriented models, semi structured data models, older models like the network model and hierarchical model. These are the different type of models. Okay, we will study one by one. So first we are going for the entity relationships model. So that any object or anything we are doing at that particular instance of time, it can be a thing, it can be a name, it can be a file, that we call it the entity. For example, we are worried about the banking data management system for the customer depositing some amount in his account. Okay, he has already opened an account there, he want to deposit. Understand? Then how we establish relation between them? For example, you see, this is the in the rectangle, this is the relation. Okay, so you can see here. So customer is a relation and account is a relation. and the customer deposits money in the account. How do you describe the customer? A customer must have a customer ID. The customer must have a customer name. Customer must have some address like the street and city. Similarly, account there must be some account number, and in the account there must be balance. Maybe zero balance also, because some salaried accounts they can be zero balance also. So whatever they may be, that is according to the condition of the bank. Now we understand the customer is a depositor of amount in the account. So this is the entity relationship. So what are the entity? Customer is the entity, and account is the entity. Means here it is just like table, customer table, account table. So what sort of relation exists between the customer and account? The customer always try to deposit or withdraw money from the account or on the account. Then entity relationship model we are continuing. ER model of real world. See, entity means we call about any object. It can be the customers, it can be the account, it can be the bank, branch, etc. Relationships between the entities. Account A, suppose there are account number A101. Actually, this type of account doesn't exist, but I say, suppose the account number is A101. So it is held by a particular customer, say Johnson, and the relation ship said a depositor associate customer with the accounts. That means this is the account of this particular custom Johnson, and this custom, this person, this customer, it has an account there and it is depositing some money, right? Then why this is the entity relationship model? It is widely used for database design. In database design, ER models usually converted to design in the relational models coming up next, and which is used for the storage and processing, right? Now let us see an example of the relational model. Suppose we maintain a relation or a table like the customer. In the customer, we have the customer ID. You can see the first column, these are the customer ID. Second column, that is the customer name. Okay. This customer ID, customer name, customer street, these are all the schemas, you understand. And the customer ID value is equal to 192 hyphen 18. This is the instance of that schema. You got it now? These are things I'm telling. And for this customer ID, the customer name is Johnson, and the street is something like that, and also the city account number is this thing, right? So from this now you can clearly understand. So one, we have taken one relation customer ID. In the customer, these are the different schemas and these are the different values for that particular schema at a particular instance of time. So this is relational models. They are maintained just in a tabular data. Tabular means there must be some rows and columns, and these columns are the attributes. These columns are the attributes. You can clearly or the property, whatever you say. Say suppose I go for the customer table. A is the customer table. In the customer table, we are having customer ID, customer name, customer street, and customer city. Again, here we are having the account table. B is the account table. So left hand side below the account table. Account table, we are having the account number and the balance here. Say this is in dollar or rupees, whatever you which region you belong. You use it like this. You got it now. So now what I want to say you. Similarly, I am going for a depositor table. Depositor table, for depositing, there must be a customer ID. The money is deposited in that cost. This is the customer ID, and this is the account number. Because customer ID is required, also the account number is required. So there you have to deposit whatever the amount. You got it now. So these are the three different tables, and we maintain relationship between them. That right. Then we go for the different type of the languages and database. There are two type of languages in the database. That is the data definition language or the DDL. Second one is the data manipulation language, the DML. Okay. Then first we go for the DDL. Says for example, we are going to create a table, that is the account table. So how do we create in the Oracle or like that? We create table account. Your account number, it is a character, and the maximum it is size is 10. So balance is integer. Like that we created the table. So you got it as the database schema we created. You got it. In the database schema, there is no what the account number is not given there, and balance not given. But he is telling the database table created account, and the account number it must be character. Character means it will also take character and number, everything. That is not a problem. Then balance is purely integer, right? So DDL compiler generates a set of tables stored in a data dictionary. Okay. So this is the thing. The DDL the DDL compiler, it generates a set of table stored in a data dictionary. That try to understand. In the data dictionary, it contains metadata. That means data about data. What are the contents? First is the database schema. Second one, data storage and definition language. Okay, languages in which the storage structures and access methods used by the database, we call it the data storage language or the definition language. Usually, an extension of the data definition language. Next, we go for the data manipulation language. Data manipulation language. This is the languages for accessing and manipulating the data. So first the data is stored, then we can manipulate or we can access the data. So how do we access? By using some query language, structured query languages, SQL like that. Okay. Select all from this one. This is the condition satisfied. We would do it like this. Then DML is also known as a query language. We call it as a query language. Query means we ask a question. Say for example, you as a student, your result is declared. So in the university website, the result is declared. You go there and you write your registration number and you get your result. So this is the query you are putting. What is my result? When my registration number is this one or number is this one, then you get yes, you passed with A grade, and your grade is 9 point something. You get it that there are two classes of languages. One is the procedural language, second one is the non-procedural languages. Okay, I'm talking about the different classes of languages. What is the procedural and what is the non-procedural? The procedural, user specifies what data is required and how to get that data. Okay, both are there. And what is the data you want and how to get data. So because I want this data and this is a procedure, how you can get that. That's why I call it as the procedural language. Coming to the non-procedural language, I want the data. How you get that is your job. I don't tell how to get that one. That is the non-procedural. SQL is mostly widely used query languages. We are going for that one here, right? Now we focus on this SQL. SQL or the we call the structured query languages, right? So it is widely used in the non-procedural language. So SQL is not a procedural; it is a non-procedural. Remember it. SQL is a non-procedural because we want the data and how get the data that I do not know. You write the query language how to write, then you get it that. For example, we find the name of the customer with the customer ID. This one, see, it is easy because now you're writing the query languages and you easily find it there. Then you imagine that in the CSV file or in the Excel sheet, you want to find the name with this thing. It is a hard job, and you control find like that lot of things you have to do it there and vary the data because now you are using small relation on table. Suppose a huge table is there, lakhs of data is there, so it is tedious job for you. So now, how do you write the query language here? Suppose select a customer database and from that customer name. Okay, select customer. Try to understand. Select customer dot customer name from customer where customer dot custom. You understand what is the table name? Table name is customer. Okay. So now from the table, what you are going to select? Customer dot customer name. I want to select the customer name from the table customer where customer dot customer ID is something. That means he's telling when the customer ID is this one, and try to select his name. Immediately you get it is a Johnson or somebody. What is the name against him? I will get that one. So suppose I say find the balance of the account held by this customer ID. Then what you want to see? Because where that balance is there in the account. So select the balance from account. Try to understand. I want to select what? The balance from where? The select account dot balance from depositor and account. Why? Here we are having two tables because try to understand this customer ID what you are telling giving it may not be there in the balance. You get it now? In the so that's why to get that balance you must use the table account and to get the customer ID you must use the depositor, right? Depositor means a customer ID must be there. You get it? Depositor means I have already shown you a customer ID will be there and also the account number should be there. You get it now? This is the reason you cannot get it from one table. That's why we are selecting two tables, that is the depositor, comma account 2, and from that get or select the account dot balance where and what is the condition where depositor dot customer ID is equal to this one and depositor dot customer name is account dot account number. Why these things are there? Try to understand because there is some common attribute or property. Okay, try to understand what is that one? Account number. Account number existing in the depositor, account number also existing in the account because These two different data is available in two different things. Then how do you get that one? To get that one, you must have a common property. From that common property, you can link both the things. For example, account number is common in depositor, account number is depositor. Suppose this is the account number is something like that A101, for example. Okay. So this account number, where it is there? Because it is there in the account, it is also there in the depositor. So he is telling, when both the numbers are same, and that means another condition is that on the customer ID is this one. In that case, you find the account balance from the depositor and account table, right? So this is how you write the query languages. For details, you can refer the textbook by uh, Korth. Okay, so more number of examples and things you quoted there. So you'll have clarity about, or if you need more details about writing all the query languages in details, we will have separate video for that one. This is only I'm showing you how to use the SQL. Then application programs generally access database through one of the languages extensions to allow embedded SQL. Then application programs, what is the application of this program? Embedded SQL is there, ODBC, JDBC is there, interfaces which allows SQL queries to be sent to database. Okay, what is our queries are there? That queries has to go to the database because you are writing a query here. Okay, so we need some interface. So which this query has to go there and it is collect the data and return to you, right? So this is done. Then who are the database users? Users are differentiated by the way they expect to interact with the system. For example, one is the application programmer. Application programmers, they interact with the system through DML, data manipulation language. Okay, through data manipulation language, the application programmers, they interact with the system. Okay, database management system. Then sophisticated users, they form request in a database query language. Okay, then the specialized users write specialized database applications that don't fit into the traditional data processing framework. Then the naive users invoke one of the permanent application programs that have been written previously. They are the naive users. Suppose example is that people accessing database over the web, bank tellers, and the clerical staffs, they are the naive users, right? Then what are the database administrator? See, database administrator is it coordinates all the activities of the database system, and the database administrator has a good understanding of the enterprise information, resources, and needs. Then the database administrator duties, what is the duties? He has to define the schema definition, storage structure and access method definition, schema and physical organizations modification, granting user authority to access the database, who can access and what amount data you can access and what type of data you can access, specifying integrity constants. Say suppose the minimum balance account should be 5,000, so that constant he has to set, or next time it is 10,000, he has to set. Acting as liaising with users, so user and bank some issue is there, so liaising work is to be done by this fellow, and monitoring performance and responding changes in the requirements. Everything is taken care by the database administrator. Second one, the transaction management. A transaction is a collection of operations that perform a single logical function in a database application. Try to understand. So this transaction is a collection of operations. Okay. So addition, subtraction, whatever things are there, that perform a single logical function in a database application. And this transaction management component, it ensures that the database remains in a consistent, that is the correct, means before the use and after the use there should be consistent stage, right? State despite the system failure or power failure, whatever it may be, and the transaction failures, there are so many issues. There can be internet failure, there can be power failure, system may crash, somebody can hack, some issues can be there. Then the concurrency control manager controls the interactions among the concurrent transactions, because the same time your account is accessed by more than one people. That is the concurrent transactions, to ensure the consistency of the database, right? Then the storage management. The storage manager is a program module. All these are program modules. Try to understand. The storage, there is no manager sitting there physically. Storage manager is a program module that provides the interface between the low level data stored in the database and the application programs and queries submitted to the system. And the storage manager is responsible for the following tasks. So interaction with the file manager, efficient storing, retrieval and update of the data. All the things it is taken care by there. So if you see the overall things, you see the disk storage here at the bottom. Above that, we have the buffer manager, file manager. You can have these things: file manager, authentication, integrity, transaction manager. Then above that, we are having see application programming, object code, query languages are there, DML, data manipulation language, DML queries, DDL, and compiler. Then above that, the application interfaces, application program, query tools, and also administrative tools. And at the top, we are having naive users, what I told you that, and the application programmer who write, and the sophisticated user who use, and the database administrator who use it for specific purpose. So these are the and some of the applications architectures you can put it there. Suppose we are having the client and server. So user applications, etc., and through a network it will be connected to the database systems. It's a two-tier architecture. Try to understand it's a two-tier architecture. What it happens, the user using a application in the client, and through a network it is connecting to a server, okay, database system. But in the three-tier architecture, what happens, user and application client is there through network. First it is going to the application server, then it is going to the database system. Here directly it is going to the database system, but above the database system he is having application server through application server. So this is called the three-tier structures. The two-tier architecture, the client program using ODBC, JDBC to communicate with the database. But in the three-tier architecture, web-based applications and applications built using the middleware. A middleware is used, that is the application server. Using that one, we are going for that one. These are the things. So with this, we have covered the basic of database management system. I hope you people have understood the things. If you have any query, please do send a mail or SMS to me. And also, if you like this, please share the video with others. And also, don't forget to subscribe. Thank you. Thank you for watching this video. Take care of your health.